Okay, so now we come to the second part of today's asynchronous lecture, and we're gonna start with a new section, which is the last section for chapter 3 part 2 as well as chapter 3 punya topik lah. So with this, habis yang ni, kita habislah chapter 3. Yay! Alright, so we will end chapter 3 with concavity of a function. Apa maksud concavity of a function here? So as the definition stated here, if the graph of f lies above all of its tangents on interval I, then it's called concave upward, or on interval I itulah, where it implies its f double prime x is more than 0. Where the other way around, if the graph of f lies below all of its tangent lines on an interval I, then it is called concave downward, or f double prime x less than 0. Okay, so for you to determine whether the function, kalau daripada graph, for you to determine whether the function is concave upward or concave downwards is by checking its tangent line. Faham kan? At the beginning of chapter 3 part 1, definition of derivative. Okay, we do discuss what does it mean by tangent line and how it relates with derivative kan. Okay, tak ingat play balik video episod berapa pun saya tak ingat dah. Okay, so you see here for the graph concave upward, kalau tengok tangent line, it only touches the curve at one point kan. Katakanlah point kat sini. So this is the tangent line. So nampak tak, tangent line ni berada di atas ataupun di bawah? Okay, terbalik. The curve, okay, the graph ni berada di atas atau di bawah tangent line. Okay, as you can see, tangent line ni kat bawah, curve kat atas. Okay, the curve is above the tangent line. Okay, so that's why it is called as concave upward. Ataupun you can say dia punya melengkung ke atas. Okay, dia melengkung ke atas. Okay, the tangent line is below the curve, ataupun the curve is above the tangent line. Macam belajar bahasa Inggeris lah pula. Alright, as for concave downward, kalau you tengok graph ni, okay, graph, the second graph on my right here, okay, concave downward, where should we place the tangent line? Tangent line touches the curve at only one point. Katakanlah this point. So as you can see here, the tangent line is above the curve. Ataupun we can say the curve is below the tangent line. Ataupun you boleh juga, untuk pemahaman you nampak kan curve ni dia melengkung ke bawah. Okay, dia melengkung macam ni. So this is so called as concave downward. Or if through equation you may check, you may test, you will find out that f double prime x is less than 0. Right? Okay. So let's analyze this example 11. Kita try untuk analyze the curve here. Okay, we have start from A to H, the point here. Kita ada dia punya interval A to H here. So let's determine the concavity interval for the curve below. So tengok, kalau curve ni, yang ni, okay, nampak yang macam ni. So concave up ke concave down? Kat mana patut kita letak dia punya tangent line, ke atas ataupun kat bawah? So definitely tangent line berada di atas, curve ni melengkung ke bawah. So this is concave downward. Sama juga yang ni, sebenarnya dia macam ni, dia melengkung ke bawah. So this one is concave downward. Okay, yang ni alright, so yang ni dia macam ni. Okay, lepas tu bila naik graf ni macam ni. Okay kelas, untuk you nampak clear, saya lukis balik graf ni supaya, sebab the curve kat sini dia macam tebal sikit ink dia kan. So macam maybe it's hard for you to see actually whether it's concave upward ataupun concave downward, dia punya bukaan dia tu. Alright, so now kita repeat balik. Yang ni lagi clear lah sepatutnya lah. Kalau tak clear, you lukis sendiri lah. Okay, so this one, okay, you can see the curve ni, dia nampak tak dia melengkung ke bawah. Yang ni pun dia melengkung ke bawah. So this is concave downward, this is concave downward, So this one also dia melengkung ke bawah. Okay, dia punya shape ni melengkung ke bawah. If you want to put the tangent line will be on the above the curve. So this is concave downward. Tapi bila dah masuk kat sini, nampak tak? Dia melengkung ke atas. Where should we put the tangent line? The tangent line should be below the curve. So this is so called as concave upward. Yang ni pun sama. Okay, yang ni saya ubah sikit lah ni. Yang kat sini ni dia jadi melengkung ke atas. Okay, melengkung ke atas. So this is concave upward. Tapi bila sampai ke sini, nampak tak? Dia melengkung ke bawah balik. So within this interval from G to H is actually concave downward. Okay, so it's just for your understanding lah yang ni untuk nampak. I think it's more clear kalau you tengok yang ni kan. Alright, okay. Alright, so now we have, okay, the last thing that you need to know for this chapter 3 part 2 here, or chapter 3 as well, okay, is what we call as inflection point. Point of inflection. Apa maksud? Inflection point here is the point where the curve changes from concave upward to concave downward, or from concave downward to concave upward. Okay, from concave downward to concave upward, or from concave upward to concave downward. Macam yang tadi, kat example yang kita ada yang ni dulu. Okay, boleh tak kita identify where is the inflection points? Okay, maknanya tempat perubahan. Dia berubah dari concave upward ke concave downward, ataupun concave downward kepada concave upward. So kalau you nampak, kita ada point E kat sini. Yes. This point E is what we call as the inflection point, because it changes dari concave downward to concave upward. Tapi point ni tak, yang ni tak, because it does not change from concave upward, still concave upward. But yes, point G, this is another inflection point, because it changes from concave upward to concave downward. Alright, so tu daripada graph. But okay, and then here, okay, what is mentioned here at a point of inflection, okay, CFC is how we want to determine the inflection point kalau bukan daripada graph. Kalau daripada graph senang, nampak tak? Ni example yang saya another example I have here. Okay, this point is so called also as an inflection point, because yang ni sebelum this point C is concave down. Lepas point C, it concave up. So at point C is what we call as an inflection point. Okay, however, for this example, for example, yang ni inflection, dia concave up. Lepas point ni pun concave up, but then it dia tak ada perubahan. There is no changes. Dia tak berubah daripada concave up ke concave down, but it still remain concave up, and they still remain to concave up. So this one does not have any inflection point. Walaupun kat sini kita find out, okay, later we'll find out f double prime C is equals to 0. Apa maksud f double prime C tadi? Okay, kat sini maksudnya yang saya tunjuk cara just now, okay, I'm explaining to the graph what does it mean by inflection point. Yang tu senang, yang ni senang because you can just directly observe from the curve. But what if the curve is not given to you, but instead it is given to you the equation? So you may also actually determine where is the inflection point through an equation by finding at what point does it will make our f double prime x equals to 0. Okay, so inflection point occurs at a critical number. Critical number juga, tapi critical number bukan masa, kalau critical number sebelum ni kita find when f prime C equals to 0 kan, ataupun does not exist. But for inflection point, kita cari when f double prime C equals to 0 or fails to exist, does not exist. F double prime. Okay kelas, kalau critical point sebelum ni is f prime, yang ni adalah f double prime. Okay, 2 kali differentiate. Hope all of you can able to differentiate between inflection point dengan yang satu lagi tu, yang critical point yang kita dah discuss before this, when we want to find local minimum, local maximum, interval of increasing, decreasing, tu semua kita berpandukan kepada critical numbers. How to find critical numbers? When f prime c does not exist or 0. But for inflection point, when it is equal when f double prime is equals to 0 or does not exist. Alright, okay, so now we have example 11. In this example 11, we will show how do we actually find the intervals of which the function is concave up or concave down. Dan daripada situ juga kita akan find out where are the inflection points. Okay, so given to us this function fx equals to 3x power of 4 minus 4x cubed minus 6x square plus 12x plus 1. Okay, so sebenarnya soalan ni saya dah solve dah, untuk jawapan dah ada kat situ, tapi tak apalah, kita differentiate lagi sekali. So f prime x, okay, differentiate. Rasanya kita pernah differentiate ke benda ni ya? 12x cubed minus with 12x square minus with 12x plus 12. Alright. And then sebab soalan ni dia terus tanya you all untuk concavity, dia tak tanya pun bila where does the function to increase or decrease, then you can straight away jump to f double prime x. Okay, because to determine the concavity we use the second derivative. So then here we have 36x square, right, minus 24x minus 12. Okay, dan daripada sinilah, okay, to find the point interval of concavity, we are finding the inflection points, okay, or the value that we made the f double prime x equals to 0. So we have 36x square minus 24x minus 12 equals to 0. So I guess you can factor out this with factor of 12. So we have x square minus 2x minus 1 equals to 0. Okay, so what we will have here. Okay, oh sorry, I made a mistake kat sini kan. Where's my mistake? Okay, 12. Factor out 12. So, kat sini mestilah ada 3. 3x square minus 2x minus 1. Bukan x saja macam tadi. Alright, so here we try to factor. Dapat sama tak dengan dia? Of course, mesti dapat sama. So we have here 3x plus 1 x minus 2 equals to 0. So daripada sini, sorry, apa pula x minus, apa ni? Silap ni. Minus 1 lah. Okay, 3x plus 1 times with x minus 1. Kalau you factor daratlah balik, itu you will get the answer. Alright, so daripada sini, that's why kita ada 3 factors to put inside. X minus 1 and 3x plus 1. So we have the point, maksudnya kat sini 3x plus 1 equals to 0. So we have x equals to negative 1 over 3, 1 point. X minus 1 equals to 0. X is equals to 1 is another point. So that's why kat sini kalau you nampak, we have real number line test and x equals to negative 1 over 3 and x equals to 1. Alright. So kita check lah. Check for any value less than negative 1 over 3, say negative 2. So negative 3 masukkan dalam x minus 1 macam kita buat for first derivative test sebelum ni. So put inside negative 2 minus 1, you will get negative 2 times 3 plus 1, you will get apa? Negative 2 darab dengan 3, negative 6 tambah 1, you will get also negative. So negative times negative, you will get positive. So that's why kat sini kita tulis f double prime more than 0. And then in between negative half to 1. In between negative half to 1, paling senang of course, kosong lah. So put in 0 minus 1, you get negative. 0 plus 1, you get positive. Then here we get negative. Then any value more than 1, say that we use 2. So 2 minus 1, masukkan dalam ni. 2 minus 1, you get positive. 2 times 3 plus 1, you get also positive. So positive times positive, you get positive. Also more than 0, then it become concave up. So maknanya kat sini, interval of concavity, kita ada concave up. Dari mana ke mana? Concave up is from negative infinity to negative 1 over 3. And we also have another interval for concave up. Daripada 1 to positive infinity. Yang ni kan? 1 up to infinity. Whereas concave down, kita ada dari mana? Negative 1 over 3 to 1. Okay, so this is the answer. And how many inflection points do we have? Remember, inflection points are the point where the curve change direction from concave up to concave down. Or concave down to concave up. So can we say these 2 points are our inflection point? Yes, because for x equals to negative 3 ni is one of our inflection point because the curve change from concave up to concave down, and x equals to 1 is also our inflection point because it changed from concave down to concave up. Alright, clear everyone? So if you're clear, meaning that with this we have completed chapter 3, okay, part 2 as well as chapter 3. Okay, so for last class word submission, I want you to repeat example berapa saya nak suruh you buat ni? Sorry. Okay class, for last class participation point, I want you to repeat last example yang kita buat tadi, example 12, okay, using this question, okay, using example 10a, using this equation, find interval of concavity and inflection points as well lah. Okay, and inflection points only for 10A. Okay, masa you nak submit tu, I want you to complete lah. Maksudnya repeat, tulis balik apa yang saya dah discuss. Okay, maknanya find interval of concavity and inflection point tu B. Yang A, I want you to find sebenarnya bukan find lah, local maxima, local minima, and interval of increasing decreasing. Okay, bukan cari sebab saya dah tunjuk dah cara nak solve sebelum ni kan. So just that you need to understand and salin balik je lah sebenarnya. Okay, so I want you to complete, okay, everything that we have discussed in this chapter 3 part 2, where we find the local maximum, local minimum, dan daripada situ kita boleh determine whether the function is increasing or decreasing. At the same time, B, find the interval of concavity and inflection points. Alright, so only one question, but you have to, your solution has to have these two, okay, for your classwork submission today. Alright, so with this we have completed chapter 3 part 2, meaning to say I will upload this question for assignment 3 part 2 tomorrow. Okay, I'll give you some time to relax dulu. Okay, then assignment chapter 3 part 2 will be out on Monday. Okay, I'll will let you know through WhatsApp lah. Okay, so that's all for today's synchronous class, and we will update anything dekat WhatsApp lah. Okay, so thank you everyone. Assalamualaikum warahmatullahi wabarakatuh, and take care.